Before your morning coffee, you've already used space technology 5 times. Your phone's GPS, powered by satellites orbiting nearly 12,500 miles above Earth. Welcome back to Relaxing Facts Studio, where we take a calm, clear look at the ideas shaping our world. Today, we begin with something surprisingly personal: how space travel has quietly built the invisible systems that support your everyday life. When your smartphone calculates the fastest route to work, it connects to a satellite network that also powers aviation navigation, ride-sharing logistics, emergency response coordination, and even the precise timing used in financial markets. Modern commerce depends on that orbital accuracy. Satellite communications extend even further. Live broadcasts, international video calls, and broadband access in rural communities all rely on space-based infrastructure. Schools, hospitals, telehealth providers, and small businesses remain connected because satellites bridge gaps where ground networks cannot. Space research has also shaped consumer products. Memory foam, refined for aerospace safety, now improves comfort and impact protection. Advanced thermal insulation, originally engineered for spacecraft, contributes to energy-efficient buildings. Scratch-resistant coatings, developed for astronaut visors, influence durable eyewear and optical lenses. And perhaps most critically, Earth-observing satellites monitor atmospheric pressure, ocean temperatures, and storm systems in real time. That data improves hurricane forecasting, strengthens disaster preparedness, and protects communities. Space technology isn't distant. It operates quietly above us, supporting safety, efficiency, and economic stability every single day.
Hours before a hurricane makes landfall, satellites have already mapped its structure, wind speed, moisture levels, and projected path in remarkable detail. Modern weather satellites continuously scan Earth's atmosphere, allowing meteorologists to issue earlier and more accurate storm forecasts. That added time translates directly into safer evacuations, better emergency planning, and stronger protection for homes and infrastructure across the United States. The same Earth-observing satellites monitor floods in near real time. By analyzing rainfall intensity, river levels, and soil saturation from space, agencies can identify high-risk regions before waters peak. This data supports emergency responders, insurance risk modeling, and city planners working to strengthen drainage systems and improve long-term resilience. In agriculture, satellite imagery powers what's known as precision farming. Farmers use space-based data to measure crop health, soil moisture, and temperature variations across individual fields. Instead of watering or fertilizing uniformly, they can apply resources exactly where needed. The result is higher efficiency, lower input costs, and more sustainable food production, an economic and environmental advantage. Wildfire detection has also advanced dramatically. Thermal sensors aboard satellites can identify abnormal heat signatures in remote areas long before fires spread widely. Earlier detection enables faster containment, reducing property loss and protecting air quality. Beyond immediate disasters, satellites track air pollution, ocean temperatures, and long-term climate patterns. Policymakers, scientists, and local governments rely on this information to design smarter infrastructure and protect public health. From storm warnings to food security, satellite technology quietly saves lives, delivering actionable data that strengthens safety, sustainability, and economic stability across the country.
Long before a medical device reaches a hospital room, many of its core technologies are tested in one of the most extreme laboratories imaginable: space. The sensors, originally engineered to capture faint signals from distant planets, helped refine advanced imaging systems here on Earth. Improvements in digital image processing, first developed to enhance space photography, now support clearer MRI and CT scans, allowing physicians to detect tumors, internal injuries, and neurological conditions with greater precision and earlier intervention. Miniaturization was another breakthrough driven by space travel. Astronauts require compact, lightweight, and highly reliable health monitoring equipment. That demand accelerated the development of portable diagnostic tools, including wearable heart monitors, remote ultrasound devices, and compact vital sign systems. Today, these technologies support telemedicine, rural healthcare access, and emergency response units across the United States. Materials science research conducted for spacecraft safety also influenced modern prosthetics. Lightweight composites and high-strength alloys designed to withstand extreme temperature shifts and stress are now used in advanced artificial limbs. These materials improve durability while reducing weight, helping patients regain mobility with greater comfort and control. Perhaps most significant is research on bone density and muscle loss in microgravity. Astronauts experience rapid bone and muscle changes in orbit, offering scientists a unique model for studying osteoporosis and age-related muscle decline. Data gathered from the International Space Station has informed improved exercise protocols, rehabilitation strategies, and preventive care approaches for patients on Earth. Space medical innovations are not futuristic concepts. They are integrated into imaging centers, rehabilitation clinics, and remote healthcare systems today. Exploration beyond Earth has strengthened diagnostic accuracy, expanded access to care, and improved long-term health outcomes in measurable, practical ways. Some of the most advanced technologies inside modern factories and operating rooms began as solutions to spaceflight challenges. Robotics designed to assemble spacecraft and operate in zero gravity laid the groundwork for today's precision manufacturing systems. Robotic arms, originally engineered for orbital missions, now influence automated production lines and assist surgeons in performing minimally invasive procedures with remarkable control and accuracy. In space, every drop of water and every breath of air must be carefully recycled. That necessity drove breakthroughs in water purification and air filtration systems capable of operating in closed environments. The same filtration principles are now used in municipal water treatment, portable purification devices, hospital air systems, and emergency response units. These innovations improve public health, especially in regions facing infrastructure limitations or natural disasters. Fire safety engineering also advanced through spacecraft design. Materials developed to withstand extreme heat and reduce flammability in spacecraft interiors have influenced fire-resistant textiles, insulation, and protective equipment. These materials enhance safety standards in commercial aviation, construction, and industrial environments where thermal protection is critical. Miniaturization is another lasting contribution. Space missions demand compact, lightweight electronics that consume minimal power while maintaining high performance. This requirement accelerated advances in microelectronics, sensors, and integrated circuits. Today, those innovations support smartphones, environmental monitoring systems, wearable health trackers, and smart infrastructure. NASA's research ecosystem operates as a technology incubator. Innovations developed to solve the constraints of space travel consistently transition into commercial applications. The result is a steady pipeline of high-value technologies that strengthen healthcare, manufacturing efficiency, environmental safety, and consumer electronics, quietly shaping industries far beyond the launch pad.
Orbiting roughly 250 miles above Earth, the International Space Station functions as a continuously operating research laboratory, one where gravity is no longer the dominant force shaping biology, physics, and engineering. In microgravity, cells behave differently. Proteins crystallize more clearly, and fluids move in unexpected ways. These conditions allow scientists to study disease mechanisms, immune responses, and cellular aging from new angles. Research conducted aboard the ISS has contributed to improved drug development methods and a deeper understanding of muscle and bone loss, directly informing medical research on Earth. Food production is another area of measurable impact. Experiments in hydroponics and controlled environment agriculture aboard the station have refined techniques for growing crops without soil. These innovations support vertical farming systems, urban agriculture projects, and resource-efficient greenhouses across the United States. By optimizing light exposure, nutrient delivery, and water use, space-based research helps increase yields while reducing waste. Water recycling aboard the ISS is exceptionally efficient. Astronauts rely on closed-loop life support systems that reclaim and purify water for reuse. The engineering principles behind these systems have influenced advanced filtration technologies used in remote communities, disaster relief operations, and off-grid facilities where reliable water access is essential. Long-duration missions also provide valuable psychological insights. Living and working in confined environments has helped researchers better understand stress management, teamwork dynamics, and mental resilience. These findings inform best practices for isolated work settings on Earth, including submarines, research stations, and remote industrial sites. The ISS is more than a symbol of international cooperation. It is a practical research platform generating data that improves medicine, agriculture, resource management, and human performance worldwide.
Some near-Earth asteroids contain concentrated deposits of nickel, iron, cobalt, and even platinum group metals, materials essential for electronics, renewable energy systems, aerospace manufacturing, and advanced batteries. Using space telescopes and spectral analysis, scientists can identify the chemical signatures of these objects without ever landing on them. This early-stage mapping is the first step toward evaluating which asteroids may hold economically valuable resources. The long-term goal is not reckless extraction, but controlled, highly automated operations conducted in space itself. Robotic mining systems, autonomous drilling technologies, and in-orbit material processing are being studied as ways to reduce the need for environmentally disruptive mining on Earth. Instead of launching heavy materials from our planet, future missions could process metals in space and use them to build satellites, space stations, or solar arrays directly in orbit. This concept feeds into what analysts call the emerging space economy. Off-Earth materials could support satellite manufacturing, deep space exploration infrastructure, and large-scale space-based energy projects. Industries such as advanced manufacturing, robotics, artificial intelligence, and aerospace engineering would all play central roles in developing this ecosystem. Integrating space-derived materials into global trade would require new economic frameworks, international agreements, and transparent regulatory systems. Financial modeling already explores cost per kilogram comparisons, long-term supply stabilization, and strategic resource diversification. While still in development, asteroid mining represents a shift in thinking, viewing space not only as a frontier for exploration, but as a potential extension of the global resource network. If executed responsibly, it could expand supply chains, reduce environmental strain on Earth, and open a new chapter in high-technology industry.
Above Earth's atmosphere, sunlight is constant, unobstructed by clouds, seasons, or nighttime cycles. That simple fact is driving serious research into space solar power. The concept of placing large solar arrays in orbit where they can collect energy far more efficiently than ground-based panels. In space, solar panels can receive nearly continuous sunlight, dramatically increasing potential energy output compared to systems limited by weather and daylight hours. The next step is transmission. Engineers are studying methods to convert collected solar energy into microwave or laser signals, which could then be safely beamed to receiving stations on Earth and converted back into electricity. Early prototypes and laboratory demonstrations suggest that wireless power transmission over long distances is technically feasible under controlled conditions. The focus remains on efficiency, precision targeting, and international safety standards. If scaled successfully, space solar farms could provide a steady source of renewable energy, complementing terrestrial solar and wind systems. Because space-based arrays are not affected by local weather patterns, they could deliver consistent baseload-style clean energy, potentially strengthening grid stability and reducing dependence on fossil fuels. However, significant engineering challenges remain. Launch costs, in-orbit assembly, long-term maintenance, radiation exposure, and energy conversion efficiency all require further innovation. Advances in reusable rockets, lightweight materials, robotics, and autonomous assembly systems are gradually improving feasibility. Space solar power is not science fiction. It is an active area of aerospace and energy research. If developed responsibly, it could expand renewable energy capacity, diversify national energy strategies, and redefine how humanity captures one of its most abundant natural resources, sunlight.
Behind every rocket launch is a complex economic engine powered by engineers, software developers, materials scientists, data analysts, and advanced manufacturers. Space exploration has become a high-value sector within the broader aerospace industry, generating skilled jobs in satellite production, robotics, propulsion systems, cybersecurity, and mission control operations. These are not temporary roles. They are long-term careers tied to research, infrastructure, and commercial space services. The rapid growth of private space companies has expanded this ecosystem. Startups focused on satellite communications, Earth observation data, reusable launch systems, and in-orbit servicing are attracting venture capital and institutional investment. This innovation cycle drives competition, reduces launch costs, and accelerates commercialization. As a result, space technology increasingly intersects with telecommunications, cloud computing, artificial intelligence, and geospatial analytics, industries already central to the U.S. economy. The ripple effects extend into education and regional development. Demand for aerospace engineering, advanced manufacturing, and computer science skills strengthens STEM programs at universities and technical institutions. Local suppliers, from precision machining firms to electronics manufacturers, benefit from long-term government and commercial contracts. Entire innovation hubs have formed around spaceports and research centers, stimulating housing, infrastructure, and small business growth. International collaboration further amplifies economic impact. Joint missions, satellite partnerships, and shared research initiatives foster cross-border investment and technology exchange, while maintaining regulatory oversight and safety standards. The global space economy now represents a significant and growing market segment. Space exploration is not just a scientific endeavor, it is an economic catalyst. It supports high-tech employment, encourages entrepreneurship, strengthens supply chains, and contributes measurable value to advanced industrial sectors. It's often described as a luxury. Rockets, astronauts, distant planets, but the data tells a different story. Space exploration underpins systems that modern economies depend on daily. Satellite navigation supports aviation, shipping logistics, emergency response, and digital banking timestamping. Weather satellites protect infrastructure and agriculture. Communications satellites power broadcasting, broadband access, and global connectivity. These are not abstract benefits. They are embedded in critical national infrastructure. The perception of wasteful spending often overlooks measurable return on investment. Historically, government-funded space research has generated commercial spin-offs in materials science, telecommunications, computing, and medical technology. Innovations originally developed for spacecraft and orbital missions have transitioned into private industry, strengthening high-value sectors and creating skilled jobs. Economic analyses consistently show that research and development funding in advanced technology fields produces multiplier effects across supply chains. Return on investment is not only financial. Space-based Earth observation improves disaster preparedness and environmental monitoring, reducing long-term recovery costs.
Precision agriculture, powered by satellite data, increases efficiency and stabilizes food production. Miniaturized electronics, developed for space missions, accelerated the evolution of consumer devices and digital infrastructure. Looking forward, emerging areas such as space solar power, in-orbit manufacturing, and asteroid resource assessment could influence future energy systems and supply chains. Continued research also advances robotics, artificial intelligence, and remote healthcare technologies. The question is not simply whether space exploration is worth the investment. The evidence shows it already functions as a strategic driver of innovation, infrastructure resilience, and economic competitiveness. Rather than a distant ambition, it is an integrated component of modern technological progress.
Thank you for staying with us on this incredible journey through the real benefits of space exploration. If you haven't subscribed yet, hit that subscribe button so you never miss a calm, fact-filled adventure with Relaxing Facts Studio. If you enjoyed this video, please like it and share it on your social media to help more people discover these fascinating insights. I'd also love to hear your thoughts. Drop a comment below and tell me what surprised you most or what ideas this episode sparked. With your support, this channel can continue to grow, inspire, and bring more amazing stories to life.